Okay, the recording has still, okay, now the recording has started. So we start here. Now you all know that the instantaneous frequency is now omega I of t, which we have said is nothing but d theta by dt, right? Now, if I am not doing any kind of modulation, there is no modulation taking place, there's no information signal present. At that time, the instantaneous frequency of the signal will be nothing but the carrier frequency. Since we are taking a carrier sinusoid, I am taking a sine wave as a carrier signal having a frequency omega c. Now, when I'm not doing modulation, the carrier frequency will remain as omega c. The amplitude is fixed as A. The phase, to make things simpler, I am keeping theta naught is equal to 0. So when no modulation is taking place, that time omega I of t will be equal to omega c. Now in case if the modulating signal is appearing, at that time when the modulating signal was not present, that time the carrier frequency was omega c. Now, as my amplitude of the modulating signal increases, my carrier frequency also increases. As the amplitude of the modulating signal reduces, the frequency of my carrier also reduces. This is what we called as frequency modulation. That means as soon as my modulating signal comes, my carrier frequency will change. It will change by how much amount? That amount is directly proportional to the modulating signal. And that's why we reflect the effect of the modulating signal as omega c plus m of t. Now, it means that my carrier frequency is going to vary as my modulating signal changes. To represent this, that means my carrier frequency will be directly proportional to the changes that take place with the modulating frequency. Now, since it is directly proportional, when I say directly proportional means what? As my modulating signal voltage is increasing, my carrier frequency is increasing. As my modulating signal voltage is reducing, my carrier frequency is reducing. That's why we can say that omega c is directly proportional to m of t. Now, in order to represent this proportionality, we use a constant which is called as kf. So, my instantaneous frequency in case of Fm is going to be omega c plus kf m of t. It is going to be omega c plus kf m of t. Okay. Now, I want to write the equation of Fm. I know how to write the equation of a sinusoid. The equation of a sinusoid is nothing but A cos of theta of t. Now, when I say it is A cos theta of t, I know the relationship between the angle and the instantaneous frequency. The relation between the angle and the instantaneous frequency is it is theta of t is equal to integral minus infinity to t omega I alpha d alpha. Why do we take alpha? It is just the variable of integration. So instead of taking it as t, we are taking it as alpha. So now I can find out what is my theta of t. My theta of t will be nothing but equal to integral minus infinity to t into bracket omega c plus kf. Now instead of m of t, I'll take it as m of alpha d alpha. So what will I get over here after integration? I can take this integral inside. Omega c is a constant. So omega c integral minus infinity to t d alpha will be nothing but alpha. The limits going from minus infinity to t. So this becomes t plus kf is a constant, proportionality constant. Keep it aside. It becomes kf integral m of alpha d alpha. Integration limits going from minus infinity to t. Therefore, my equation for Fm becomes A cos into the angle. What is my angle now? It is omega ct plus kf integral minus infinity to t m of alpha d alpha. So thus we have got our equation of Fm. So this was my equation of Fm. Okay. This is how, once you understand the concept of instantaneous frequency, you will be in a position to write the equation of Fm yourself. Okay. Now, once I have understood how to write the equation of Fm, writing the equation of Pm is quite simple. Now, when we are saying about PM, it means that it is phase modulation. Okay. When I say phase modulation, my equation of a sinusoid was A cos of theta of t, which was also equal to A cos of omega ct plus theta naught. Now to make it simple, theta naught is nothing but the phase. Okay. To make it simple, we assume theta naught to be as 0 because I don't have to do anything with theta naught. It is just the phase of that sinusoid. So let's assume it is 0. So let's make this as A cos of omega ct. So my angle now is omega ct. Now I am talking about phase modulation. Phase modulation is what? As the amplitude of your modulating signal increases, the phase of the sinusoid increases. As the amplitude of the modulating signal decreases, the phase decreases. And phase is represented in the form of the angle over here. It means that my omega ct is directly proportional to m of t, which I can write it as omega ct plus kp m of t, where kp is representing the proportionality constant in phase modulation. Now, if I want to write the equation of phase modulation, again, I will be using the same concept. It will be A cos of the angle. What is my angle in this case? It is A cos omega ct plus kp m of t. So this becomes my equation of phase modulation. These two are very important questions for phase, for frequency modulation as well as